Hello, this is the second video that is devoted to production costs. In it, I'm again gonna loosely follow chapter 5 in the textbook, and today I'm gonna focus on one particular set of questions, firm's decisions in the short run. You might recall in the previous video, we said that in the short run, a firm's level of capital is fixed, and the only thing that the firm has to decide is how much output to produce, and correspondingly how much labor to hire. And I'm going to revisit the example from the previous video in which we'll be using a Cobb-Douglas production function. That is a production function in which the amount of capital and labor are multiplied by each other and they're taken to a particular exponent. And so in this story, output is 10 times square root of capital times square root of labor. And in the short run, the amount of capital is fixed as 25. So we can go ahead and first we can plug in 25 in place of capital in the production function. Square root of 25 is 5. So the coefficient for labor becomes 10 times 5, 50. So output is 50 times square root of labor. And so if the company wants to produce a particular amount of output Q, it can use Q to put it into this equation and solve for L and find out how much labor it needs to hire to produce that output. And the solution to that is labor has to be output over 50 squared, so Q squared divided by 2,500. That is the idea with respect to how much labor to hire. The company wants to produce Q, hire Q squared over 2,500 units of labor. Now, what about the cost of production? We know that the costs have two components, the variable labor component and the fixed capital component, and the standard assumption is that the labor market and the capital market are both competitive in the sense that no matter how much labor and how much capital you're willing to buy, you're still paying a fixed flat price, W for unit of labor, R for unit of capital. So the total cost of production is W times the amount of labor that you need, that is Q squared over 2,500, plus 25 times the cost of capital, because 25 is how much capital you're getting in the short run. Now let's plug in some numbers for the wage rate and the real interest rate. Let's assume that the wage rate is 125 and the interest is 200. And then our total costs become 125 times Q squared over 2,500 plus 25 times 200, so it's Q squared over 20 plus 5,000. And you can see by looking at the total cost that there is a constant term here, that's the fixed cost, the fixed component of the total cost. And then there is a component that increases with an increase in the output. That's going to be your variable cost. So Q squared over 20 is going to be the variable part, the labor cost, 5,000 the fixed part, the cost of capital. Now, the next question is, how much should the firm produce? And we're going to look at the situations in which a firm is a price taker in the output market as well. So suppose it's going to be facing a particular market price, and no matter how much or how little it's willing to sell, it's only going to be able to sell it at that market price. So we're going to implement the usual marginal analysis. You want to find out how much it costs you to produce each additional unit of output, and so for that you need to calculate the marginal cost of production, and you need to compare those marginal costs with the marginal benefit of selling that output in the market. And so first, let's figure out the marginal cost from the total cost. The way I want you to think about the marginal cost is as the derivative of the total cost function with respect to quantity. So that if you were to increase quantity slightly, the derivative will show you the change in the value of the total cost. And so let's look at the two components. The fixed cost of 5,000 is a constant, so its derivative with respect to Q is going to be 0. We can ignore it. And the first term is a quadratic term, so it has Q squared over 20. And the derivative of Q squared is 2Q, so we'll get 2Q divided by 20, which gives you Q over 10. So the marginal cost is just Q over 10. The first unit will cost you 1/10 of a dollar of additional costs, the 10th unit will cost you $1, the 100th unit is going to cost you $10, and so on. So marginal costs are clearly increasing. The more you're willing to produce, the more an additional unit of output costs. What do you have in terms of the marginal benefit of output? Well, in a competitive market, if you're a price taker, your marginal benefit is just the market price at which you're willing to sell your output. And clearly, you have to be producing as long as you can make money by selling the units you produce. So you're earning the price, you're paying an additional Q over 10 in the costs. If the difference is positive, then the unit should be produced. As you produce more, your costs increase, so you should stop producing when your marginal cost hits your level of the marginal revenue equal to the competitive price. So the condition that tells you what output will maximize your profit is the condition Q over 10, that is marginal cost, equals marginal revenue equals the price. And so if we rewrite it in a slightly different way, it says Q has to be equal to 10 times the price. And at this point, you should stop and say, this looks suspiciously like a supply function because we just have a relationship between quantity and price. And in fact, it is a supply equation with one small caveat. And the caveat is the variable cost. Are you actually covering your variable costs by producing a positive amount, or would you be better off by producing nothing at all? So let's look closely at this trade-off and this question. So here are the costs of the firm, and just like I said, there is the variable component and the fixed component. And the important thing about the fixed component is that you have to pay it no matter whether you decide to produce anything at all or nothing whatsoever. So think about 5,000 as something that you bury in the ground. What happens when you produce a positive amount? You would choose quantity that maximizes your profit by setting marginal cost equal to the price. And if you produce a positive amount, your profit will be the difference between the total revenue, that is price times quantity, minus the variable cost of production, minus the fixed cost of 5,000 that you have to incur. If you choose to produce nothing, your profit is going to be negative 5,000 because the fixed cost has to be paid no matter what. So if you look at these two options, you can see that producing a positive amount is better if total revenue exceeds the variable cost of production. So forget about the fixed cost. As long as producing covers the additional variable costs of production, you're better off producing rather than not producing. So optimal quantity gives you higher payoff as long as total revenue exceeds your variable cost. Now, if we take this inequality, divide everything by the price, so we'll get divide everything by the quantity, so we'll get price minus variable cost divided by quantity. This condition can be also written down as price has to exceed the average variable cost of output. So if the market price is higher than per unit cost of producing the optimal level of output, then you should still be producing. And we will call the minimum average variable cost the shutdown price. If price is below the minimum average variable cost, then no positive level of output makes sense. You should always be producing nothing if price is too low. This is the lowest price. And it's sort of counterintuitive, but in the short run, it's sometimes optimal to produce a positive amount and lose money because of the fixed cost. Basically, in the short run, your benchmark for profits is not profit of zero, are we making positive profit or negative profit, but rather, are we making a profit above negative 5,000 by producing? Or if not, we should stop and not produce anything at all. So your benchmark is the negative fixed cost rather than zero. And with this total cost equation in mind, let's look at the profit levels for different prices. So I'm going to look at price of 10, price of 25, and price of 40. And in all of these cases, producing nothing earns you profit of negative 5,000. So let's convince ourselves that producing the optimal amount would be better than producing nothing for all of these prices. So when the price is 10, optimal quantity has to be 10 times the price, 100, and the profit that you get in this case is going to be negative 4,500. So the profit is negative, but it's better than just losing the 5,000. Basically, you pay 5,000 up front, and then after you pay the 5,000, you get the 500 back in terms of revenue minus the variable costs. So you're losing money, but you're not losing as much as you would have lost by not producing anything at all. When the price is 25, optimal quantity is 10 times 25, 250, and profit is negative 1,875. Still bad, still negative, but better than producing nothing. Finally, when price is 40, optimal quantity is 10 times 40, 400, and the profit becomes 3,000. Clearly, producing is better than not producing. So for all these three prices, they do exceed the average variable cost of production at the corresponding output levels. And so in all these three cases, it does make sense to produce a positive amount. Now, an additional question that you want to ask yourself is, for what price is the profit actually going to be 0? You can see that it has to be somewhere between 25 and 40. And in fact, if we do a calculation, it's going to be a price of 31.6. And we call that price the break-even price because you earn 0 profits. That is, you're exactly breaking even. And let's remember this number because I'm going to show it to you once again a little later. So here's a summary of the firm's decision making in the short run. First of all, we're looking at a firm that is a price taker, both in the inputs market and the output market. So it can sell its output at a fixed price P, and it can buy labor and capital at the fixed wage rate W and interest rate R. Optimal output, from the firm's perspective, optimal positive output solves the equation price equals marginal cost. So given the total cost, find the marginal cost, set it equal to price, and solve it for Q, and you'll get optimal quantity that the firm should be producing. The general rule, though, is that the firm should be producing nothing if the current market price is below the average variable cost of output, and otherwise, if price is above the average variable cost, produce the optimal quantity as described in the second bullet point. And so to distinguish the border between producing nothing and producing optimal quantity, we'll call the minimum average variable cost the shutdown price. When the price is below the shutdown price, the best thing is to produce nothing. Next step, the firm will make negative profits if price is less than average cost of output, less than cost per unit of production. So there could be a situation when the price is above the shutdown price, but still quite low, that the profits will be negative. And I've showed you in the previous example, prices of 10 and 25 were just like that. And for with respect to negative or positive profits, we think about minimum average cost of output as the break-even price. If the price falls beneath the minimum average cost, which was 31.6 in our example, then it means that the firm is going to be making negative profits. If the price is above 31.6, it's going to be making positive profits. So as a summary of a summary, a price-taking firm has 3 regions. When the price is very small, when the price is below the shutdown price, the firm should be producing nothing. When the price is above the shutdown price, it has to be producing optimal quantity. If the price is above the shutdown price but below the break-even price, optimal output gives you negative profits. If the price is above the break-even price, optimal output gives you positive profits. Now, the next thing that I would like you to do is I would like to calculate all the costs that I was talking about for the total cost equation that I used in my example and graph them so that you will also get a graphical explanation of what is going on. So with the total cost of q squared over 20 plus 5,000, you'll get marginal cost of q over 10. For average variable cost, you need to take the variable cost component q squared over 20 and divide it by the output level to get q over 20. And for average cost, you need to take the total cost in general, divide them by output. So q squared over 20 divided by q plus 5,000 divided by q to get q over 20 plus 5,000 over q. And if we graph them on the same graph, we should get a picture like that. The blue line here is the marginal cost, q over 10. The red line here is the average variable cost, q over 20. And you can see that marginal cost is always above the average variable cost in this example. And the yellow U-shaped curve is the average cost, which has two components, q over 20, the average variable cost component, and 5,000 over q, the average fixed cost component. So what are the observations that we get from the graph? First of all, the supply curve of this firm will coincide with its marginal cost curve whenever it lies above the average variable cost. So in our example, the whole blue line is the supply curve. The higher the market price, the more output the firm is willing to produce, because at every price, it's going to be covering its variable cost, and thus its profit is going to be higher than the fixed cost, than just losing the fixed cost of 5,000. That's the first observation. The blue line, think about it as the supply as well. Second observation, the average cost or average costs are U-shaped. Why are they U-shaped? Well, look at the two components. When q is small, average variable cost component q over 20 is rather small as well. The red line is very low. But when q is small, the average fixed cost component is large, because you take the 5,000 that you pay for the capital, and you have to divide it evenly between the small output that you're producing. So the average fixed cost component will be large. As output increases, 5,000 over q gets smaller and smaller and goes towards 0, whereas the average variable cost increases. So the higher the output, the closer the red line and the yellow line will be to each other. So we start very high, and then we fall, and then we go up again. Small levels of output, average fixed cost is high, average variable cost is low. High levels of output, average variable cost is high, average fixed cost is low. But their sum is always above a certain level. That's the second observation. Third observation, if the marginal cost is below average cost, so if the blue line is below the yellow line, that means that the yellow line has to be decreasing. It has to have a negative slope. If the blue line is above the yellow line, then the yellow line has to have a positive slope. Marginal cost is the cost of an additional unit. And if an additional unit costs less than the current output on average, then the average cost of output, including that additional unit, has to go down. If an additional unit costs more than what it costs now on average, then with more output, the average cost has to go up. The consequence of this fact is that the intersection of average costs and marginal costs take place exactly at the minimum of the average cost, which is also known as the break-even price. So there is this very convenient coincidence that when the market price is the break-even price, the firm finds itself at the point of production where exactly it's going to be making zero profits. So we're going to look at it in more detail when we talk about firms in the long run. And finally, let's look at graphical example of what happens to the firm's decisions when we set a particular price for the output. So suppose in this example price is 50. So here's our price level of 50. The blue line, the marginal cost intersecting with the price, should tell us the optimal level of output. So it has to be at 500. So our optimal output is at 500. And let's see what other information this graph contains. First of all, well, we can say, what is the total revenue in our situation? It's price times quantity. Price is the vertical side of this rectangle, quantity is the horizontal side of this rectangle. So the whole area, sorry, I'm jumping ahead. I'm going to show you this. Total area underneath the price level bounded by the quantity level is the total revenue. And that is going to be $25,000. So selling 500 units at $50 a piece gives you $25,000. The average cost that corresponds to the output of 500 can be found at the intersection of the vertical bar at 500 with the yellow curve, the average cost curve. And you can calculate, you can check my calculation that the average cost is going to be 35. And so price is above the average cost. So it looks like the firm is going to be making positive profits. With the average cost of 35, the total cost is just going to be average cost times the number of units it sells, 17,500, and it's also a rectangle because 35 is the vertical side. This is how much we spent per unit on average. We sell 500 units, so we spend a total of $17,500. And clearly the difference between total revenue and the total cost is going to be the profit. So the profit is the leftover green rectangle of $7,500. If on average it costs us $35 to produce a unit of output, but we sell it at $50, then per unit on average we're making $15 in profits. So per 500 units the profit is going to be $7,500. And this is all that you need to know about the firm's decision making in the short run. Thank you.